8.10, volume with disk method when we're revolving around something other than the x or y axis. It's basically still our same formula. We have volume equals pi times the integral from a to b of r squared, and then either dx or dy, depending on if we're revolving around something that's parallel to the x-axis or y-axis. So basically, just to draw a quick picture here, the graph is negative x squared plus 2. It's going to look something like that. And then the line y equals 1. So we've got this, and it wants us to revolve that from 0 to 1, and I'm just making this up, but we're basically figuring out if we revolve this around this way. So we're revolving around that line y equals 1. So you've got this little bit. So now r is the distance between this and this is your r. So let me move this out of the way. Take our little picture here. Then our volume is equal to pi, and it tells us from 0 to 1. And since we're revolving around an axis that's parallel to the x-axis, we use x values for our bounds. Then our r is negative x squared plus 2 minus 1. And that gives us, I didn't write 1. So minus 1. And this is dx because we're revolving it parallel to the x-axis. So this top graph is the negative x squared plus 2. This orange line is y equals 1. So the distance between those is negative x squared plus 2 minus 1. So then b equals pi 0 to 1. And you could type it in exactly as it's given above. I usually like to simplify it. So 2 minus 1 plus 1. I forgot my squared up here. Squared dx. So pi out front, r squared from here to here. And now, if I up here, I'm going out of order here, but the volume would be 8 over 15 pi, or about 1.676. And we can do that on the calculator. I'm just going to do one on the calculator because really once you get the setup, that's all you need. None of these have trig in it, so it doesn't matter what mode you're in. You're going to go alpha window. We're going to integrate. And I probably should have done pi, then alpha window, integrate, and then I'm going 0 to 1, and I had negative, well, let me back up. I need a set of parentheses because I need everything that's being integrated to be in the set of parentheses. So now negative x squared plus 1, close my parentheses, squared. That way everything that I wrote down is in that set of parentheses that were given. And then dx and we get the 1.676. Now, me personally, I would have done 1.6755, but the answer sheet says 1.676. So that's how you do that on the calculator. All right, clear that off. Now our next one is going to be very similar. It always helps if you want to draw a little graph. So negative x squared, it's just going to be like this. And it wants us to also draw the line y equals -1. And it wants us to revolve it around this line. So that's going to be that space. So we need to figure out what these intersections are, and those will be the bounds. So if we just set up here negative x squared equal to -1, because the purple one is negative x squared, the orange is -1, we just need to see where they intersect. Divide both sides by -1, x squared equals 1, so x equals plus or minus 1. So that tells us to integrate from -1 to 1, and we're going to do our negative x squared, the top one minus the bottom one, so that's minus -1, all of that squared dx. And again, I'll simplify it. You don't have to, but I like to. So we get negative x squared plus 1 squared dx. And you can put that in the calculator. Again, make sure you put the extra sub parentheses. It might work if you don't, but it's a good habit to get into. And we'll get the volume equals 16/15 pi, or about 3.351. So those are revolved around the x, well, not around the x-axis, around a line parallel to the x-axis. So everything's in terms of x, your bounds are in terms of x, all of that. This time, it wants us to revolve around this line. So we're going to be revolving that way. And it's a little harder to graph in terms of y, so I generally don't graph it. You can if you want, but what I do is I know that my bounds are going to be, and this ended up being part of the graph as well. So I'm just going to see where these intersect. So I'm going to say -2 equals square root of y minus 2. Add your 2, you get 0 equals square root of y. So we get y equals 0. So here, and then it says y equals 1. So we know our bounds, our upper and lower bounds, are going to be 0 to 1. So I know that I'm doing volume. For my bounds, I'm using y values, 0 to 1. And what I need to do is see which of these is bigger in that. So if I put in a half, square root of a half, let's just do that on the calculator. The square root of 1/2. And then it was minus 2. So that's -1.29. I don't care what it is. I just know that it's bigger than this. So I'm going to say square root of y minus 2 minus -2 all of that squared. And this time, since we're in terms of y, it's dy. So that just tells me that this graph is further to the right of this line. So we simplify this. And then square root of y minus 2, this becomes plus 2. So we just get square root of y squared dy. And you can type that in your calculator, or you can just, that one's pretty straightforward. It's just going to be y from 0 to 1. And you have to integrate that. But it would be 1/2 pi, or about 1.571. Then delete this. All right, lastly here, again, we sketch a quick graph just to see where our bounds are. We know the axis, which is one of the lines. They want us to rotate it around that. And x equals negative y squared. You can solve that a couple ways, but again, I don't ever graph it. But I do need to see, well, I don't need to, because it gives me the bounds right here. From y equals 0 to y equals 1. So that tells me 0 to 1. And so I'm just going to see in between which is bigger. So if I do a half again, a half squared is a fourth. Negative a fourth is bigger than negative 1. Negative 1 over here, negative a fourth over here. So that tells me that in this range, this is the bigger one. So I do negative y squared minus negative 1 squared dy. And again, we're just finding the radius for when we rotate. So 0 to 1, negative y squared plus 1. Got to square that, because again, pi r squared. And this time, we're going to get a similar answer to before. V equals 8 over 15 pi, or 1.676, or again, 1.6755. Big things to remember there is when you're revolving around an axis parallel to the y-axis, your bounds, upper and lower, these are going to be y values. Right? That's a y value. That's a y value, right? Lower bound, upper bound. And then whatever you're rotating around, you take this minus the axis that you rotate around, square the whole thing, integrate.